Hey there, this is Mr. Alexander, and today I want to cover transformations of rational functions, which is what we covered in Pre-AP Algebra 2 on February the 10th and February the 11th. I hope you remember that the parent function for the rational function is y equals 1 over x, or, if you prefer, f of x equals 1 over x. So let's talk about that parent function a little bit. First thing is, if we were to make a table of values for this thing, f of x, it would look a little bit like this. So if you've got -9, you plug in -9 over here, that becomes -1 over 9. And if you've got a -3, that becomes -1 over 3. If you've got -1 over 2, well, that becomes -2 like that. And if you have 0, well, 1 divided by 0 is undefined. So this thing approaches 0, but never quite touches it. And if you remember the graph of this thing, there's a couple of asymptotes that intersect at 0, 0. This asymptote is y equals 0. And this one is x equals 0. And this graph has points here and here. And it goes up that way forever and over that way forever. So this is kind of what the rational function looks like this. Now, so it's got one horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. The intersection of those asymptotes is at the origin, 0, 0. And the domain of this thing, it goes to the left forever and it goes to the right forever, but there's just one spot where it does not touch this graph. And it's at 0. So the domain is all of the x values except for 1. Or sorry, except for 0. And the range is the same way. It's all of these y values except for that one at 0. So when we're making transformations of this thing, we're shifting it left or right, we're stretching it, but in the end, we're just moving this one point around where the intersection of these two asymptotes is. And that's what I want to show you today. So let's think of an equation. Let's say f of x equals 1 over x plus 3 minus 6. Now let's see if we can identify the transformations there. I see two of them. One of them has to do with this plus 3. The other one has to do with this minus 6. The plus 3, remember, if it's next to the x, like this, that's going to shift the graph left and right. And I like to think of this as counterintuitive. Since it's a plus 3, it's going to move this thing to the left 3 units. And this minus 6 on the outside, that's going to move it up or down. On the outside here, up and down. Since it's a minus 6, that means we're going to shift it down 6 units. So that's pretty simple. Let's see if we can do another one. Let's rewrite it as 3 over x plus 1 plus 4. Here I see 3 transformations. Let's start from this side. That plus 4, well, that makes the graph go up 4 units. It shifts it up 4 units. And this plus 1 shifts it left. Remember, counterintuitive. left 1 unit. Now this 3 on the top here, that's an interesting one. That's multiplying 3 to this x here. Another way I could write this is I could write it as 3 times 1 over x plus 1 plus 4. What that 3 does is a vertical shift. Sorry, a vertical stretch by a factor of 3. That's what that 3 does. Now let's talk about how to graph some of these. So let me make up one again. Let's say f of x equals, and let's do 1 over x minus 3 plus 1. And there's 2 transformations, right? One of them is the minus 3, the other one's the plus 1. The minus 3 is counterintuitive. That means it goes right 3 units. And the plus 1 means it goes up 1 unit. So, from 0, 0, I'm going to go right 1, 2, 3, and up 1. I'm going to put a dot right there. I know that this is the intersection of my 2 asymptotes. So I'm going to draw 1 vertical as a dotted line and 1 horizontal as a dotted line. So I've got my 2 asymptotes. Now from here, all you need to do is first identify which quadrants it belongs in. And this one belongs in quadrants 1 and 3. I'm going to put a dot here and a dot here. And then I simply need to draw this graph going in both directions asymptotically, approaching these asymptotes. So that's what that thing looks like. It's never going to quite touch these asymptotes, but it gets really close. So what if I wanted to know the domain and range of these things? Well, first let's identify the asymptotes. That's usually the easiest thing to do. There's always 2 of them. The vertical one and the horizontal one. The vertical asymptote is x equals 1, 2, 3. See that x minus 3? And that x equals 3. The other one, the horizontal one, is y equals 1. Same as that one. Now from these asymptotes, I can figure out the domain and range pretty easily. The domain is every single x value except for where that asymptote is. So you can just say x does not equal 3. And the range is every single y value except for where that asymptote is, which is at 1. So y cannot equal 1. And that's essentially everything that we have to cover in this lesson. If you can do this, you're in good shape. So let's do another one. Make up a whole new one. Let's make one like this. F of x equals negative 1 over x minus 1 plus 4. And the first thing I like to do is identify the transformations. And I see 3. 1, 2, 3. First I see a plus 4. And that tells me this thing goes up 4 units. And I see this minus 1, and I think counterintuitive. So that means it goes right 1 unit. And finally I see the negative. And the negative is what makes this thing a reflection. So this thing reflects. So what's that mean? Start from 0, 0, and go up 1, 2, 3, 4, and go right 1, put a dot. And I know that this is where my asymptotes are going to intersect. So I'm going to put some dotted lines where those asymptotes are. And one vertical, one horizontal. Now, since it's a reflection, we're not in quadrants 1 and 3. Now we're going to be in quadrants 2 and 4. That's what a reflection does. So I'm going to put one over here and one over here. And I'm going to draw my lines from there. So this one goes that way forever, and that way forever, and this one goes this way forever, and this way forever. And they never intersect the asymptotes. So that's what the reflection does. It takes it from these two, switches them over to these two. So let's identify what those asymptotes are this time. Remember, there's always two. X equals for the vertical one, and then y equals for the horizontal one. In this case, it's x equals positive 1, and y equals 4. And once you have the asymptotes, it's really easy to find the domain. It's all the x values except for that one. So x cannot equal 1. And it's really easy to find the range as well. It's all of the y values except for that one. So y cannot equal 4. That's it. Well, why don't we do one more like that? Okay, last one. F of x equals 1 over x plus 2. And this time I only see one transformation. That's this one. It's that plus 2, which means I go left 2 units. So I'm going to start from 0, 0, and go 1, 2, left. That's where my new starting point is. I'm going to put in my horizontal asymptote and my vertical asymptote. And it's not a negative, so I'm in quadrants 1 and 3. So I'm going to put a dot here, put a dot there. This one goes up like this, like that, and like that. It's going off, and the off to infinity in both directions except for right there. So the asymptotes. And at this point, hopefully you can get the asymptote from the equation. It's just going to be the opposite of that. It's going to be x equals negative 2. That's the vertical. And the horizontal is this one right here, y equals 0. And then, of course, the domain is all of the x's except for that one, where the asymptote is. And the range is all of the y's except for where the horizontal asymptote is. And that's it. That's the whole lesson. Hope this was a useful video. Thank you for watching.